Hello, this is Group 6's Week 6, Chapter 10, Enable Fast and Reliable Automated Testing, DevOps Principle of Flow. My name is Gary King, and I've been working with Ferdan Huerta on this presentation. Just an introduction, the goal here is to create technical practices and architectures required to enable and sustain the fast flow of work from development into operations. We don't want any chaos or disruption to the production environments or our customers. We want to reduce the risks associated with deploying and releasing changes into production. And we want to implement a set of technical practices. To start this off, the first thing that the chapter talks about, as should be the first thing that you want to build, is you want to automate as many of the manual tests as possible. You want to find as many code errors through these automated testing suites, and you want to reduce the reliance on manual testing. This will allow you to move so much faster as you can have your developers test at any time, 24/7, and those automated tests always run faster than the manual ones. This will work on high-value activities that, and then you'll work on high-value activities that you can't automate, like exploratory testing and testing improvements. So we want to continuously build, test, and integrate our code and environments. We want to build quality into the products at the early stages. Developers have to build automated tests as part of their daily work. They need to get in the practice of doing that so that they can run more automated tests and automate more of the testing process. It helps to create a fast feedback loop that helps to find problems early and fix them. With an automated testing, you can move right from commit to test and get the results right back, instead of having to push on to a testing team to test, wait for them to give you feedback, and then you know what changes you need to make, then you have to make those changes, then retest again. Whereas this is like, you test, if there are any problems, you can go right back, fix it, test again, get the results back immediately. Currently at the place I'm working at, we're very much on the manual testing, and so there's a lot of delay that is just associated with that, and so it takes a while for us to hear back from our testing team. You want to build fast and reliable automated validation test suites. So you want to automate these tests into one of the following categories, from fastest to slowest. The fastest being unit testing. Test a single method, class, or function and isolate it and ensure that the code operates as designed. So this is very easy to automate. You automate it, test cases and stuff to test different parts of the code. The acceptance testing, this is a much more manual one. This is the higher level of the functionality. Operates as designed. You usually test the whole application, often if you can, with user groups or end users that will be using the application, so you can get their stories of how they use the program, how it works for them, if it's working as they intended it. Then integration testing. This is to ensure that the application correctly interacts with all your other production applications and services. And this is one that can go both ways. There, I've seen some automated testing of some integrations where you can test and see if your application integrates with some other applications. Just automated, run some data through it and get the feedback right back. I've seen others where it's more of a manual process, but if you can automate as much as possible there to save time. So we want to catch errors as early on in our automating testing as possible. We want to run faster automated tests so that we can find those errors early on. If most of the errors are found in the acceptance and integration tests, the feedback is slower than with the unit tests. Errors detecting during integration testing are difficult and time-consuming, and validating the fix is difficult. What we want to do is we want to move with the ideal testing automated pyramid. We want to do automated unit testing that moves to automated component testing, that moves to automated integration testing, that moves to automated API tests, moves to automated GUI tests, and then you can do your manuals so that you've already passed all those kind of tests. The automated side. Non-ideal, you have to do the manual test first. You're going to be waiting a long time before you can then move to the automated GUI test, integration test, and unit testing. We want to start with the automated and move to the manual. You want to ensure that the tests run quickly and in parallel if necessary. You want the need to design our tests to run in parallel, potentially across different servers. You need to run different categories of these tests in parallel. Any build that passes all the automated testing should be immediately available for exploratory testing. such as performance testing. You can see if you follow this manual or this automated process here, you move straight from commit to accept to capacity testing. It's just a straight shot. Manual approval, you have to commit, then you have to go through the exploratory testing, and then the production, and so it's a slower process there. So we write our automated tests before we write the code, and we do this to ensure that we have reliable automated testing, and it's written to test those parts of our daily work. If we have the test written before we even start to develop, we kind of start with the end in mind, what we want the program to do. We come up with some things that we're going to be testing it on, and then we can write the code to really facilitate that. The techniques such as a test-driven deployment or acceptance test-driven deployment, we want to ensure that we have test cases that are going to fail. We're planning on that. Because we want to know basically the extent of the program. Every program has things that it can handle and kind of a threshold of where you want to stop. And you also want to ensure you have some test cases that pass. When we give good data that the program's supposed to handle, we want to make sure that it passes. And when we give it data that we don't want it to be able to handle, we want it to fail. And we want to refactor both the old and the new code to make it well structured there. Then we want to do some integrate performance testing into our test suite. Our goal here is to write and run automated tests that validate the performance across the entire application stack. If we know how our application environments will behave under the production-like load, we can plan and detect conditions such as when our database queries grow non-linearly and when the code changes. Change causes the number of database call sources to increase tenfold. When we see these dramatic increases, we want to be doing things to those. To integrate non-functional requirement testing into our test suite, we need to enforce the consistency and correctness of the following. We got to support these supporting applications, databases, and libraries, even though they're non-functional requirements here. They're not part of what we were building. We need to make sure they work. We need to make sure the language interpreters, the compilers all work with our systems, the operating systems, and any other dependencies we got to be looking for. And then when we run into any issues, we need to pull our and-on cord with the deployment when the deployment pipeline breaks. We're going to create a virtual and-on cord. We're going to create some system where we can quickly communicate to everyone, hey, something broke. So that everyone gets an alert there that's involved. Configuring the version control to prevent further code commits until the first stage. And we want to create visible indicators so that the entire team can see when the build or the automation testing fails. I know at one company we actually had like a police light and siren that would go off when we were hitting a major issue. And so that's basically our and-on cord. When we see that, we go, oh yeah, we have a major issue. We all got to stop whatever we're doing and focus on fixing the issue. And when we pull that and-on cord, we need to fix the problems as they occur. And that's why we need to pull that cord. And we need to this allows us to prevent issues from releasing to customers and from causing further problems. If you let a problem just sit and ignore it rather than fixing it right away, oftentimes more things build on top of that, and that problem just really grows. So in conclusion, we kind of created an outline set for automated testing. We talked about the importance of those automated tests, how you really want to build those to start off with. You want to confirm that you have a green build so that you run those tests so that hey, I got a green build, it's passing deployable. And we talked about the deployment pipeline and how we want to deploy things into production. We want to follow those steps, and then we want to stage the implementation for continuous integration. We want to continually be able to build and work together there. This is going to allow teams to be independent, to work independently and safely test and deploy code into the production, and it's going to deliver value to our customers.